Today we're working on Chapter 7, Section 1, Solving Systems by Graphing. All this means is you have two linear equations, for example, y equals 3x plus 5 and y equals negative 1/2 x minus 2, and you put them on the same graph and you figure out where they intersect. Okay, so it's two linear equations and you're solving it by figuring out where these 2 points, where these two lines intersect. So let me show you what I mean. Here we have two linear equations, y equals 4x plus 1 and negative x plus y equals 4. I'll quickly remind you how to graph each of these and then we'll see the intersection point. So let's first look at y equals 4x plus 1. Looking at that graph, we can figure out two things because it's in slope-intercept form. So we can figure out the slope and we can figure out the y-intercept. So let's do the y-intercept first. Notice this is positive 1 plus 1, so our y-intercept is 1. So let's just put a point. Remember, our y-axis is the vertical line. So we'll put a point on positive 1 on the y-axis. The next thing we can see is that the slope is 4, but remember the slope has to be a fraction, so we'll change it to 4 over 1. So here I'll go up 4, 1, 2, 3, 4, 1 to the right. Or, instead of going up and right, I could do the exact opposite and go down 4, 1 to the left, which would give me those points there. And then to create the line, I just draw a straight line going through all the points. All right, now our next equation, negative x plus y equals 4. Notice that this is in standard form. Standard form is ax plus by equals c. And when you're given this form, you could change it to slope-intercept, or you could just figure out the x and y intercepts, remember, by plugging in 0. So first I plugged in 0 in place of x. So it's 0 plus y equals 4. Well, the 0 just goes away, so we get y equals 4. So on the y-axis, again, that's the vertical line, I put a point at positive 4. And now let's do the same to figure out the x value. So in order to figure out the x-intercept, I plugged in 0 in place of y. So we have negative x plus 0 equals 4. And again, the 0 goes away, so I know that negative x equals 4. This is not done yet because there's still a negative 1 attached to that x, so I need to divide by negative 1 on both sides. That way the negatives cancel on the left, so I'm left with a positive x, and then 4 divided by negative 1 is negative 4. So the x-intercept, which remember the x-axis is the horizontal line, is at negative 4. And then again I draw a line to connect those 2 points, and now I can see where the two lines are intersecting. The point where they intersect is right here, so that would be 1, 5. The ordered pair 1 and then up 5 right there. What that means is this ordered pair is the only solution for both of these equations. Let me show you what I mean. Y equals 4x plus 1. If I plug in 5 in place of y and then 1 in place of x, this should be a true statement. Well, obviously on the left we just have 5, and then on the right 4 times 1 is 4 plus 1 is 5. 5 is equal to 5, so it works for that first one. And then let's look at our second equation, which is negative x plus y should be equal to 4. So negative x would be negative 1 plus 5, and we want to see if that equals 4. Well, yes, negative 1 plus 5 is 4, so that's a true statement. That's the only ordered pair that will work for both of these equations. All right, that's graphing systems, but I want to cover one more thing to make sure you understand. If you ever end up with a graph that looks like this, there's nothing more you can do. If you have two lines that are completely parallel, since they will never intersect, all you have to say is that there's no solution because they're never going to cross. So there will never be an ordered pair that will satisfy both of these graphs, both of these equations. And the other kind of graph that you might end up with is something that looks like this. And I tried to show you, I tried to do it in black and red so you could see that there are actually two lines overlapping each other. If you get two lines that end up being the exact same line, you have to say infinitely many solutions because everything on this line can be a solution. Every one of these ordered pairs is a solution for both of these because it's the same equation. All right, that's all for systems of equations. Bye, guys.